bump in the wire is not a unique solution to us. Many industries and areas have it or contemplated it. Um, what we've done here, a couple of things that are unique. Number one, we've based our initial solution on an Intel FPGA, a small, very powerful, low-cost FPGA. So not only does it ensure that we can address the security issues today, but an investment in this relatively low-cost device will give us the adaptability going forward, because the horizon for the attacks, the nature of the attacks, are continuously evolving. And typically, as you'll see in many, many articles, when they talk about buying something that's connected or the IoT, they always say make sure you have a way to update to the latest patches and fixes and what have you. So not only do we have a very powerful platform to provide the technology, but we have one that will allow adaptability. For the building space, what was critical is that we had a relatively simple plug and play solution. So it's a very simple plug in, plug out between the controllers and the edge devices that are already installed, typically running on some sort of IP platform or network. In the building automation space, our initial solutions are designed for the BACnet world, which again is a building automation standard for how devices in buildings communicate. So our device is running. It runs the initial ones, NIST approved legacy, what I refer to as legacy protocols and methods for certification purposes. But other versions of it will run quantum resistant crypto, and we should talk about that for a minute, which is critical for long-term protection. And of course, finally, this is BACnet, which is a building standard. It runs over BACnet IP. We've developed other technologies that coordinate with it to ensure that you can also monitor the discussions that are going on. So we're creating, in the summary is, we're creating a secure tunnel from the controller to this bump in the wire device with encrypted data flowing over a BACnet compliant communication. So we don't replace anything that a building currently has or anything in the standard. And then it protects the device it's plugged into behind it. So that's a very simple description of this device, and it's designed to be flexible in the protocols it manages and what have you. And a lot of that power and flexibility again comes from the ability of having this FPGA background platform that will allow us to adapt it and some unique functionality capabilities as we move through the building space.